Hello everyone, this is M. Niranjana from 1st MSc Physics at Hindustan College of Arts and Science. I am here to explain the angular momentum of a rigid body. So let's get into the topic. So what is angular momentum? Angular momentum is a rotational analog of linear momentum. It is an important physical quantity because it is a conserved quantity. The total angular momentum of a closed system remains constant. Angular momentum has both direction and magnitude, and both are conserved. If the rigid body is taken as a rigid collection of particles, then angular momentum is given by L is equal to summation I mi into Ri cross Vi, where m is the mass of the body, R is a position vector, and V is the linear velocity of the body. Then summation I mi into Ri cross Ri is equal to summation mi into Ri cross omega cross Ri, where Vi is equal to omega cross Ri, which is equation number 1. In the given figure, a rigid body is rotating along the axis with angular velocity omega, along the axis q, with a angle theta. By using the equation 1 and the fact that omega is same for all the particle, we expand vector triple product to give L is equal to summation I mi into omega r dot ri minus ri dot omega vector into ri, which is equal to summation I mi into omega vector into ri square minus ri minus omega vector into ri. The vector involved in this equation is L is equal to I Lx plus J Ly plus K Lx, which is equal to summation mi into I omega x plus J omega y plus K omega z into Ri square minus Ri dot omega vector into I x I plus J y I plus K z I, which is equation number 2. Since Ri dot omega vector is scalar, it will be multiplying factor for coefficients of I, j, k, and equating each, we obtain I Lx plus J Ly plus K Lz, which is equal to summation mi into I omega x plus J omega y plus K omega z into Ri square minus xi omega x plus yi omega y plus I xi plus jy to yz plus kzi. That is I into omega x summation I ri square minus xi square minus omega y summation I mi into xi yi minus omega 2 summation I mi xi zi plus j into minus omega z summation I mi xi yi plus omega y summation up to I mi into ri square minus yi square minus omega 2 summation I mi yi zi plus k into minus omega x summation I mi xi zi minus omega y summation I mi yi zi plus omega z summation I mi into ri square minus zi square, which is equation number 3. Since I, j, k are components of angular momentum, Lx, Ly, Lz in terms of angular velocity components, we emphasize this linearity by introducing 9 quantities, which are Ixx, Ixy, Ixz, Iyx, Iyx, Iyy, and Izx, Iyz, Izz. Therefore, Lx is equal to omega x I zmi into ri square minus xi square minus omega y summation I mi xi yi minus omega 2 summation I mi xi zi, which is equal to I xx omega x plus ixy omega y plus ixz omega z. Similarly, Ly is equal to minus omega x summation I mi xi yi plus omega y summation I mi r square minus y square minus omega 2 summation I mi y z I, which is equation number 4, which is equal to iyx omega x plus iyy omega y plus iyz omega z. Then Lz is equal to minus omega x summation I mi xi z I minus omega y summation I mi yi z I plus omega z summation I mi into I square minus z I square, which is equal to L zx omega x plus Lzy omega y plus Lzz omega z. So that's all for the angular momentum of a rigid body. Hope you are understood. Thank you.